I'm Nicky, and I was so expecting that not to go on to the next slide. And I am terrible at overnight support. I first went on to overnight support about a decade ago. I was working for a French bank. I can't tell you much about when I got the first call, though, because apparently I answered my phone, although I have no recollection of this. I got into work the next day and got quite a bollocking from my boss for not actioning a P1 issue. We worked out what had happened. I'd actually answered the call in my sleep and thought I was taking a mission from James Bond. I didn't open my laptop, strangely enough. But this started making me think about resilience in our systems. Since then, I have worked at the FT, a newspaper in the UK, and we were redefining all of the content APIs that were the backbone behind a lot of the products there. And we were doing it from the ground up, completely re-architecting and moving towards the sort of autonomous, empowered teams that you see now, and all in the cloud. It gave me a lot of ability to be able to look at not just the technical solution, but the operational support that we were providing as well. Since then, I've moved on there. I've only been at Skyscanner for about 6 weeks, but I'm seeing a lot of the things that I talk about in this talk, and I've actually incorporated some Skyscanner stuff being done there, just at a completely different scale, often. So nowadays, we're building these really, really complex distributed systems. This diagram, which, you're not supposed to be able to read, is some of the services at Skyscanner. It was just somebody tried to map out only the Java services, and this is from February, so it will be a little bit out of date. We can't keep all of this in our heads. Sorry, I'm not coordinating my arms properly. We're not keeping all of this in our heads at the moment. We cannot keep all of this in our heads. Martin Fowler talked of the trade-offs when rolling out microservices. We've got to think microservices give us an organizational benefit, but they introduce a huge amount of complexity, and especially operational complexity. Not only that we are rolling out more and more little things that all need to talk to each other, we are also rolling them out much more frequently. And this is something we need to think about. The other aspect of these sort of the way we're developing nowadays is that all the squads are empowered to make the technical choices that are right for delivering the business outcome they've promised. It means that you end up with a plethora of technologies just being used within one team. And the kind of old operational support mechanism. I'm so behind on the clicking, I'm sorry. This is really a test of trying to do two things at the same time. I'm not going to do it well. Anyway, sorry, this is the slide. So this was a team I worked with a little while back. There's 4 people on the team, and this is all the technologies they were using. If you had a sort of centralized operational team looking after even a couple of these mini ecosystems, they would be overwhelmed, let alone a whole organization of them. And when we empower teams to make the choice about tech that they use, they should also be empowered to own the support model that they use to support it. We used to have our monoliths in a data center where we had people dedicated to keeping these servers up all the time. It was a completely different ecosystem to the one that we're operating in now in the cloud. Now the cloud has brought us this empowerment model. We should be empowered also to own more than just the business functionality that we're putting out there. We want to own it from start to finish. When I first joined the Financial Times, we were putting out these APIs, and they were really flaky. And so all of our internal consumers, they put caches in front of us because we weren't providing a reliable service. However, we had to then promise them that we could recover within 15 minutes. And we're talking 180 microservices system. It's a fair old beast. But we were rolling out a new version of ft.com, which meant we had to make some guarantees. If that wasn't enough, we decided we needed to move from our hand-rolled container orchestration and scheduling platform over to Kubernetes, while still maintaining that 15-minute SLA that we'd promised. Now, when I left the FT, the calls had all but disappeared. I verified this recently. I was a really bad party guest. I went round my mates at a party asking them when they'd last been called. It turns out that they'd had some calls, but it was mainly new people on the operations team that were worried. That's it. What we built here was not this mythical, kind of magical system of perfection. We just built a system that could handle some hard times. And that's kind of what I'm going to talk to you about today. Now, when I was thinking about this, I came up with sort of 5 buckets of stuff that we did to get to that point. First, though, sorry. Mike.
Go back.
No, I'm good. Okay, sorry, there is going to be a few of those moments. This originally, when I wrote the slide deck, it was in the middle of the slide deck. But I actually realised that the engineer's mindset is probably the most important thing. I could tell you so many technical ways to build resilience into your system, really clever things. However, if engineers aren't thinking about this to start with, then they just won't be done. Unfortunately, to get into the right mindset, often you need to be sporting a few battle scars before you realise the importance of it. Charity Majors, she talks a lot about observability, but this one I really like. I'm not a sysadmin, but I totally am behind her on this statement. We need to start making operability a primary concern when we're developing software. We want to constantly be asking ourselves, what happens if there's an error? Do we want to retry? Do we want to be got out of bed? Or do we actually just not care about it and just want to log it for a future day? And the teams have to support this. They have to own the way that they support this. You can't do a one-size-fits-all. They're the ones that know the functionality, so they should be the ones that define the support model that they use. They also, if you have a wider support team, say a centralized operational team, they need to work together to foster better relationships to be able to provide this support 24/7. When I was at the FT, we came up with this model. So we had a centralized operational support team, and then we had 2 buckets of engineers. And the operations team would round robin phone everybody in, 1 bucket 1 week, another bucket another week. What this gave us was a huge amount of flexibility in the way that we supported the platform. It meant that I didn't have to carry my laptop around with me at all times. I could go to the pub spontaneously and just not answer the call after the second beer. It also meant that it was much better for people with children, for example. The other important aspect of this model is that it was completely voluntary and compensated. Support out of hours is above and beyond most people's job. We should recognise the levels of stress that we put people under to do that role. Our support model also extended into the day. This is both at the FT and at Skyscanner, actually, that we have dedicated people that work on problems during the day, whether it be incidents or whether it be queries, or just improving the platform. They're constantly working on they're improving the platform, making it more stable, which has a side effect of them opening up PRs across our entire stack, not just areas that they're complete domain experts in. And this was dedicated time because we recognised that if we didn't dedicate it, people would automatically prioritise project work over it. every error, we need to start thinking about what that actually means. Does this result in that call? And when you're working and doing the intraday triaging, you're feeling the pain of every one of these bad decisions due to errors. So if you're constantly having to improve the code base, you start developing day to day in a better way to support your system. We also fed into the system that severity mattered. Here we have something called CoreOS version checker. CoreOS is a container operating system, which, if there's a major security patch, we wanted to roll that out pretty damn quick, but not at 3 o'clock in the morning. We could roll it out after coffee the next day. So we wanted to build in this idea that our alerts could give us different severities. Now, that's all well and good. We're now in the right space to start implementing some things. Everybody owns their own support model. We're actively improving the system. So the second thing is we don't want to be called for things we could catch during the day. And this is the biggest thing to avoid calls. But it comes from thinking what we could do in hours versus what we could do out of hours. The number one culprit is undoubtedly releases. They're going to cause most of the calls. And even with the best will in the world, the best testing, everything, there's still ways that your releases are going to end up breaking out of hours at some point, whether it be a slow leak, a data sort of build up that causes a break, hours, maybe even days later. Or sometimes you just don't see the scenarios you expect to see. So who's worried about deploying at 5 o'clock on a Friday evening? Is anybody going to admit to it? Okay, yeah. I like to think... I like to think that if you are, then potentially there's some ways of bringing up your confidence to do that. However, it is always a balance of risk. There's sort of the risk, how quickly can we roll back? What is the effect of if this goes wrong? And so on. The other thing is that make your deployments as quick as possible. I'm walking into a room nowadays and I'm forgetting why I've walked in there. The same as if I press that button. I've completely forgotten what the effect could possibly be 10 minutes later. We had a problem that we had our containers getting deployed 12 minutes after we published them to the container repo. And unfortunately, due to AWS networking, I could only actually get it down to a 5-minute deploy, which is still not great. So what I did is I integrated it with a Slack alert just to say, yep, gone out, so that I could verify things. You could even go one step better. I've now been introduced to the CD tooling at Skyscanner, and we have automatic rollbacks. So the tooling that we built in-house actually monitors the health checks of the service that you're putting out and the status codes it's producing. So as soon as it sees a spike in 500s, it will roll back automatically. Now, once it's out in production, we've got to have ways of verifying things. And this is testing in production. And I don't mean chucking your stuff out into production, keeping your fingers crossed and hoping for the best. I mean, there's ways that we can verify our releases once they're out there. And that might be just as simple as having a manual test with a production account. You can also have sort of synthetic requests going through your system and monitoring that gave you real-time feedback. There's a number of ways in which you could test once out there. There's a wonderful talk. I really recommend listening to this. Testing by Cindy. There's also something called Progressive Delivery by James Governor, which talks about all the different ways that you can test microservices nowadays. And a lot of them are, I've got a whole slide with all the people I reference in here, by the way, at the end. And it talks about things like canary testing, A/B testing, and all of those mechanisms that you can test once you're out there. Another great one is feature flags. You can put stuff behind feature flags and turn it off overnight if you're worried. That's one way you won't get a call from that feature. The other big thing after releases is these big batch jobs that happen in the middle of the night. Suddenly we're doing the most work when we least want to get called, which increases the likelihood, of course. Let me give you a quick example. So I've got a really simple order system here. We've got orders coming into a queue, getting processed, and then at 3 o'clock in the morning, we've got something transforming and aggregating them to send them out to a reconciliation tool. Now, it's doing all of its major heavy lifting and aggregation at 3 a.m. If we moved it over here, admittedly I've simplified this and there's probably a bit of contention with one file, but if you take in all of the orders as they're coming in real time and do the processing as much to the point of real time of getting that order as possible, it means that you'll get a quick feedback on any problems. It means that all the heavy lifting will tend to be more into the day. Right, sorry, fingers getting out. So that's the things we could have caught during office hours. But what if things do fail? Automate. Computers can do things a lot better than us at 3 o'clock in the morning. So there's a couple of things that we can really easily automate. Firstly, the kind of tooling that we're now using in the cloud really helps us. You know, we've got, whether you're into serverless or containers, it doesn't matter. If you've got Kubernetes, it will restart your pods somewhere else if it loses a VM. All of these ways of providing resilience to your system are taken care for you. Serverless does a lot of that under the hood, and some of their monitoring is built into this tooling. However, the tooling is only as good as the applications we put out there. And they need to be adaptable to change. These systems will take things and throw them all over the place. So we want our code to gracefully terminate. If it hangs around, it's no good. If it needs to be restarted so it can be shifted. Transactional. Nobody wants any half-baked data around. Clean restarts, in the same way as graceful termination, you have to expect your code to be terminated and moved. Queuebacks, another useful tool to provide clean data. Idempotent, so that you can replay these failed events. If you can just have the same event going multiple times through your service with no adverse effect, it's a real bonus. But that's ideally make them stateless. It makes it a lot simpler. So the other part of automation is that you could have complete failovers. So you could replicate your system in other regions. When you see one area having problems, you can just shift the traffic over to the other region. I am way behind that. Okay, this is how we did it in FT. It's quite a blunt tool version. We literally replicated our entire setup, both in the US and the EU. And during the day, we just location balanced the traffic to both clusters. But there was a lot of stuff there. There was 180 microservices. There was 4 different persistent stores. It was quite a lot. You can do this in parts of your stack too. But that, again, it has an operational overhead for people to understand. There is also a warning that if you have these 2 regions, you could end up infecting both at the same time, especially with a deployment. Bad deployment, both at the same time for both clusters, you've taken out everything. So always try to do at least a rolling deployment when you're rolling out changes to both clusters. This actually saved us. 2017 there was a AWS S3 outage, and it completely took out our US cluster. Nobody got called. Our automatic failover went, oh, we see there's a problem. Let's just direct all of our traffic over to the EU. I might add there is another warning in this. Make sure one region can take all of your traffic. Otherwise, yeah, you're in a whole world of problems then. Today, actually, we did a test because we're worried about that Skyscanner. So instead of the normal traffic to one of our areas, we put 3 times as much through, and wondered why things were slowing down slightly. But test it before you automatically assume your failovers will work. Also, liveness and health checks and things might not tell you the whole story when it comes to your services. Sometimes we want to understand when services are just struggling and, quite frankly, need a bit of a kick. You see this less with just straightforward RESTful kind of web services. But when you're talking highly concurrent big data services, you start to see this kind of behavior a little bit more, garbage collection kicking in randomly and such like. So at Skyscanner, this is something we did to automate kind of a kick. So our consumers are consuming off Kafka, and sometimes they'll lag. So we have all the metrics going into a time series database, and we have an alerting system off that. And what that alerting system does before it alerts us, it actually just restarts the process, the consumer process, just to do the whole in tech, turn it on and turn it off again. And sometimes that will resolve it, and if it doesn't, then we get called. So we can automate a lot, but there's still the definition of what a failure actually means to us. Understanding what your customer needs is actually not the most straightforward thing, because if you ask any customer, consumer, client, whatever, they're going to say everything's important, and you have to try to tease out of them what actually is the critical thing. Some companies, for example, at the Financial Times, it was anything affecting our brand. Skyscanner, it's anything affecting a traveller's journey. And those are those routes that you want to take special care of. And you don't want consumers telling you of when there's a problem. You want to understand as soon as possible when there's an issue. And we can do that in a combination of manners. There's also monitoring, but alerting. Now, this is not actually a quote. Sarah Wells was my boss at the FT for a while, and this is a mantra of hers. And I thought it was a very strange mantra at the start, because I used to get an error, and I used to throw an alert into a Slack channel for everything. But what you end up with is alert fatigue. Don't alert on anything that you don't intend to action. You have so many other ways to mop up the stuff off, outside of those at another date. Just logging and looking at those logs at a later date will work. The other way that we saw was really helpful was synthetic requests. Now, synthetic requests are requests that are manufactured by our system. We had a combination of creating our own manufactured requests and replaying old requests. The FT, we had an article from something like 2004 that we used to republish all the time. This was really useful in places where you end up with spiky traffic. Because at the FT, the publishing happened mostly 9 to 5, Monday to Friday, with very few publishers happening, say, in the middle of the night at the weekend. And so we ended up in a place that was like Schrodinger's platform. Was the platform dead, or had we just not had any publishers? So publishing through the stack all the time meant that we could see that it was alive. And it was really useful for preempting those failures. But we needed, alongside this, to have, again, I put the link at the end, a great talk. We need to have tracing and aggregated logging alongside to follow these issues when they did occur. And there's loads of ways you can do tracing nowadays. The way that we did it, there was no tooling when we did it, so we just purely embedded transactional IDs in and had our own tooling around it. But nowadays you've got Zipkin and Dapper and loads of other things. Lightstep, I think, is another one. We then went a step further. We decided that those critical flows that we were talking about, we needed to monitor those critical flows. So we needed to understand when they failed. And we did it via using some of the tracing we had. But we made a bit of a mistake. So I've massively simplified the entire architecture down. So we've got a content management system that's publishing content into our system and going via Kafka and saving it off to a database. Now we wanted to monitor things that came in and where they got to. So this is such an anti-pattern for microservice design. We built a publish monitor. And this ended up, unfortunately, becoming a little bit of a God service. It got brittle, and it was tightly coupled with our business flow. You needed to understand the criticality of a flow. And it became unmaintainable very quickly. So we ditched it, or started to ditch it. I'm hoping it's finished now. And in favour of using structured logs. So we moved the logs of critical events closer to the code. So we knew when something was happening. So with those logs, we then pumped them into Kinesis. And we could run streaming SQL over those logs to extract events that had happened within a certain SLA. Admittedly, there was a bit of logic now still over on the SQL side, but there was far less, because it could just look for things that were monitoring events. It meant that we could tag effectively errors throughout our process. And sorry, I've computer errors. This is me saying we are now flagging important events closer to the code rather than in a separate application. So we understand what our business needs. We've got the critical flows monitored. And so we've got all of those approaches in place. But what happens if we actually are called? We want to be in a good position if we're called. And we need to understand how best to support our system and do that without affecting service. So there's a technique called chaos engineering. And that means randomly pulling down pieces of your system and seeing if they can handle it. But you don't need to just do this for your tech stack. This works actually really well if you're trying to actually test your operational support model. You can do small outages and see how the team reacts. But when are you mature enough to be able to do this? So this is a typical sort of monolith microservice timeline. We've got the monolith over one side, we're teasing stuff out, then they're evolving further into their own, and then you get some more business functionality. But when along that timeline is good to start using chaos monkeys. Of course, it's not over on the monolithic side. You've only got one thing. You take that down, you know what's going to happen. But where on this timeline is it best? That's when you feel comfortable that your system is resilient enough to test the resilience. And it doesn't have to be automated. We know the ones that don't work, don't we? So manual simulations also work. And we did that a lot at the FT because we actually had a single point of failure in the middle of our system. So I was talking about it earlier, another similar diagram. CMS is coming in, but we only ever had this one notifier. This single point of failure, we knew we had it, we knew how to fix it, but it was quite wide-reaching. And so it was never prioritized. And so when we were doing the chaos engineering side, we didn't want to go fully automated. And so we were actually quite careful about how we did it. We did manual outages. The interesting thing about this single point of failure, though, is that it actually gave us some other stuff without realizing. So we were talking about failovers, multi-region failovers, and they were automatic. But you could do them manually, and that's exactly what we did for zero downtime deployments. When you've got a single point of failure, you can't deploy to it without it going down. So we would actually switch all of our traffic to another region whilst we deployed this single point of failure. And also that meant that everybody involved was constantly doing manual failovers. They knew how to do it, and typically in an engineering fashion, it started off with about 5 lines of commands to do it, and then 4 lines, 2 lines, and it was a tiny little command by the end of it. We all do that and make things as easy as possible, but that only became from the toil they had to go through. And I was expecting that one to go off the screen. We are also fixing things in hours, so this came back to that sort of triaging during the day. Because of that, we had confidence in understanding how to react to issues, and not necessarily solve them, but react and gain stability from the system, making it okay for us to understand how to make hard calls at 3 o'clock in the morning. If you do need to manually fix it, it has to be simple. There's some evidence out there that when woken from a deep sleep, it's the equivalent to a couple of pints of beer. And you just don't know what to do. So make any manual intervention one command or button clicks. We had a Jenkins job, really simple for republishing failed content. So we just take the UUIDs of the content, throw them in, press a button. Nice and easy. And manual failovers were easy too, as I was saying earlier. But also give people as much information in that alert so that they have it all at their fingertips. It's awful if you're trying to dig into something in the middle of the night and you're having to reference 5 databases or 2 log aggregation tools. No, it doesn't make sense. Bring as much information into the alert as you possibly can. And what you want to try to answer is, will a failover stop this happening? Are there failed events that need to be replayed? Or do I need to call somebody else? This was our alert for failures in FT. It had plain English, because this was often somebody who wasn't an engineer first getting it, or wasn't an engineer on the team first getting it. So they needed to understand the impact of the error. We had a link to the logging system, which would bring up the logs for that exact transaction. And we had details of the transactions that had failed. At 3 a.m., you're not doing pull requests, of course. You're not delving deep into the problem to solve it, nor should you. You're going to solve that problem a hell of a lot better after caffeine and with your colleagues the following day. So what you want to do is make the system as stable as possible in any which way to get you into the next working day. And that might be just failing over. Okay, your resilience is less if you're only serving traffic out of one region, but it will be a whole lot better than trying to deploy code at 3 o'clock in the morning. So we've been breaking stuff, we've been practicing everything, and all of this stuff massively reduced our need for any call-outs. And it was that important side of things being able to limp into the next day. So just to recap, engineers' mindsets, yes, we've got to be thinking about this. We've got to be thinking about it when we're writing code. How do we operate this code? Releases, think about them, batch jobs, try to avoid them at all costs. They're not always avoidable. But there's a lot of things that we can think about doing during the day that will affect the likelihood of being called. Automation, don't try to keep repeating things. Try to get the system to recover for you, but make it sensible. Automation can also kill a system. Try to understand your business critical flows and be able to react to them before your customers do. And practice. Practice makes perfect, they say. That's the way that you build confidence in supporting the system. Okay, we own all of this now. We're empowered teams. We should own our support model too. If your support isn't working, you've got to feed that back in. We should challenge the way that we support these distributed systems. The old style doesn't always work. So here's my shameless plug. I feel a little bit cheeky standing here in Lisbon saying we're hiring, not in Lisbon because it's such a beautiful city that I don't want to drag anybody away from here. But we are hiring. And here are all the links that I sent through earlier. So thank you very much.
You mentioned automatically restarting services or automating that.
Yes.
Aren't you afraid that by doing that you're hiding a small problem that maybe can be getting bigger and explode in your face and light?
Yeah, so there's kind of, we know that there might be a problem. Maybe the GC is running a bit too much sometimes and we could tune it, but it ends up being a priority that goes down our list. If it goes bang massively, then the priority will come up the list, but sometimes you end up spending a lot of effort trying to treat something that quite frankly is solved by something much easier. Delve into it if it's really causing you pain, is my advice. At the moment, this restart is actually saving us a lot of pain. Does that answer your question? So, of course, make code better and try to fix the error, but sometimes these things are easier to do than actually delving into the error. Feel like I sidestepped your question.
My question is kind of similar. How do you identify what you can roll back? Meaning, if you have a microservice architecture, you have many dependencies. How do you know that 500 is not from an external dependency? How do you know which service to roll back?
Yeah, so it's not as clever as understanding. You would never want it to be as clever as understanding the dependencies. So it comes back to testing on that side of things. So our system only looks at the service that you're deploying, and we'll look for 500s around that, or 500s maybe that it's getting back.
So you have a time window after the deploy?
Yes, yes.
Okay.
Yes. Otherwise, what I sort of advocate is just like I was talking about the synthetic requests. If you have monitoring over those, that's a really good way of kind of doing an end-to-end test. And you can do those in any environments. It doesn't need to be production. And so if you've rolled something out and you're seeing blips somewhere else, then have that feedback on top of it. But don't try to bake in business understanding and business flow understanding into your automated tooling for microservices. Otherwise, you've got a distributed monolith.
You've talked about multi-region support. On the relational databases that you may be preparing, on the writes or readers, the read-write replicas, do you have an active approach of trying to have writes on both regions, or just read on one region and write on the other region, and then the writes always goes to the same region? So
I'm going to talk about graph database because that was the one that was much more knowledgeable. It's the same principle. We actually had eventual consistency. So we had two actives being written to and read out of. We needed a little bit more resilience on our SQL side. And for the life of me, we had a really complex set of things that would happen under failovers, and it was read replica and a write database. But we had a lot of stuff that would be triggered to make sure that any publishers that had gone, we could flip to another, the primary to be the read replica, and then republish stuff over. If anybody's got a good solution to doing multi-region AWS SQL database, I'd love to hear it. I haven't come up with something that's not ridiculously complex.
I was making the question.
Yeah.
Except for AWS, it will be a simple solution. But
It depends on if you can do eventual consistency. Well, we thought we could. I don't think. I think that there's problems in that myself. I think try to choose a database that can replicate over regions would be ideally. Hi.
Hi. I was wondering about tooling that you use to implement this. So if you came to like a microservice architecture and there's no like DevOps tooling around observability, what are the top 3 things you'd pick?
Tracing and aggregated structured logging. Those are the 2 things that will get you off the ground. Some of those get more problematic as you scale. So, for example, the system I'm working on at the moment, I told you they did 3 times the amount. Well, normally, last week we hit a peak of 2 million messages a second through our Kafka. So when you start trying to do traces and aggregated logging through that amount, it starts to get a bit harder. But they would be my first 2. If you have those in place, and they're hard to go back from. So once you've implemented something, trying to roll out structured logging across 50 microservices is nigh on impossible.